Okay, in this problem, it says for two different values of r, the function y of t equals t to the r satisfies the differential equation t squared y double prime minus 12t y prime plus 42y equals 0. What are the two values of r? So to answer this question, let's make sure we understand what's going on. So we have this differential equation, right? This is a differential equation. And a solution to a differential equation is a function that when you substitute it in for y, it makes the equation true on an interval. That's what a solution to a differential equation is. Now in this question, it's not asking us to figure out what all the values of y are, right? Solving a differential equation means finding all the solutions, but in this question, we're not asked to find all the solutions. We're told that y of t equals t to the r is a solution to this differential equation. And we don't have to ask where it came from. Okay, we just need to figure out what r will work. So the question is, it's saying, you're told that when you substitute for two different values of r, so two different real numbers r, when you substitute this in, y of t equals t to the r, when that's substituted into this equation, the equation is true. In other words, when you substitute y in here, you get 0. And what are the values of r that do that? So what you can do is you can just plug in y of t equals t to the r into this left-hand side, and if it's equal to 0, see what r has to be. So let's do that. So if y of t equals t to the r is the solution, that means that we know that t squared y double prime minus 12t y prime plus 42y equals 0. Now we need to figure out what is the derivative, right? We need to figure out what this is, and we need to figure out what y prime is. We know what y is, that's just t to the r. Well, if y is t to the r, then the first derivative is what? And we're taking the derivative with respect to t, right? So that's dy dt, and that's equal to r times t to the r minus 1 power by your Calc 1 facts. And what's the second derivative? You bring the r minus 1 down, so it's r minus 1 times r times t to the r minus 2. Okay, so now we substitute those in there into this equation. So we know that t squared times r minus 1 times r times t to the r minus 2 minus 12t times y prime, that's r times t to the r minus 1, plus 42 times y, that's t to the r, equals 0. And the question is, what r will make this whole thing, become 0? Well, we can combine some terms together because I see a t squared and a t to the r minus 2. When you multiply them, that's going to give you what? T to the r. And I also see a t times t to the r minus 1 here. And when you multiply them, you're also going to get t to the r. And I have a t to the r here. So let's write that down. So I have r minus 1 times r times t to the r minus 12r t to the r plus 42 t to the r equals 0. And now what can you do? You can factor out the t to the r. So this factors out to t to the r times r minus 1 times r minus 12r plus 42 equals 0. And now you see what you can do to figure out how to make this equal 0, because I have t to the r, and then this term, you want this term to be 0, right? Now this term here, the t to the r, I mean, that's not going to be 0 because t is just a variable. T can be lots of different numbers. And so in order for this product to be 0, no matter what t is, you need the right-hand side to be 0. Right? I mean, if this side is not 0, if that's not 0, then you have some non-zero number times t to the r equals 0, and that's not possible for that to be 0 on any interval, because t isn't going to be 0 and in some interval, and then if t isn't 0, you're not going to get 0. So you need this to be 0, this r minus 1 times r minus 12r plus 42. So we need this to be 0, and okay, what value of r is going to do that? Well, I have an r minus 1 times r that becomes r squared minus r, and then minus 12r plus 42 equals 0. And that simplifies to r squared minus 13r plus 42 equals 0. And can you factor that? Yes, that factors as r minus 6 times r minus 7 equals 0. And so you have a product is equal to 0, so r minus 6 is equal to 0, or r minus 7 is equal to 0. The first one tells you r is 6, the second one tells you r is 7. So these two are your values of r. Actually, technically speaking, we should check that these work, that t to the 6 and t to the 7 for your values of y are going to work, right? So y is going to be t to the 6, y equals t to the 7. You can check that these, when you substitute it in, it's going to work. But you're told that there are two different values of r for which it does work, right? And we found that they're going to be 6 and 7. Okay, we found two values. If we found, 5 values, okay, of r, then we would have to, test them until we got 2 of them that worked. But here we got 2 values of r, and we're told that 2 of them work, so it must be these 2 values. And in general, when you, for these types of differential equations, when you solve for r, they will work, it turns out. So, so yeah, so the answer is r equals 6 and r equals 7. Okay, so let's just summarize what we did in this problem. We're told that y of t equals t to the r is a solution to this differential equation, right? So we don't actually have to do anything with this differential equation to solve it. We just need to figure out, the question is asking us what r is, so we can just substitute y equals t to the r in here. Once you figure out y prime and the second derivative, you can just plug those in. That's what we did here, right? We plugged them into this and then did some algebra and solved for r. Okay, thanks for watching.